guys, welcome to my channel Subhas classes. Today we are going to start a class on permutations and combinations made for class 11, and in this chapter generally a lot of intuitions is required to solve these problems. You need a lot of puzzle breaking techniques, a lot of innovative ideas to go through these problems. So let us have an introductory class on it, what the problems are like and how it starts. It starts with counting principle. What is counting principle? Whenever we count, suppose there are four students sitting on a single bench, then the number of students is 4. But if there are 6 such benches, each bench is full of 4, each bench is occupied by 4 students, then it is 6 into 4. So this is a technique you have started using from right from class 3 to 4. But when you are going for a large operations, there are several classrooms, there are several students, there are a lot of benches to accommodate them, then how do you do so? So you need a counting principle, and let us go for counting principle with the real ideas of relations and functions, the algebraic way of going through these problems. We are not going just for entertainment, we are going to solve these problems in such a manner that the higher problems, the level 1, level 2, level 3 problems of permutation combinations will appear easy. So let us start with counting principle. What is counting principle? It has 2 units. There may be relations or there may be functions. A problem in relation, a problem in permutations and combination may appear a problem of the category relation category or a function category. Do you know the difference between a relation and a function? Any man can marry any woman and become a part of the couple, but can any man marry any woman? In a family life we have restrictions. Some men cannot marry some women. Some women are not supposed to marry some men. So suppose I just describe the concept of marriage that is operating in India in 4 different patterns. Just have a show. I have set of women on the first set and set of men on the second set, and I take only 3 of each kind. See, the traditional ideal marriage is like this. If this is a marriage function, then any woman can marry a single man. So this becomes the traditional pattern that is running all over the world. Generally, in some birds, in many human beings, this thing happens. This is 1-to-1 type, and simply in short we call it 1-1 relations or 1-1 functions. In the second type, sometimes you will find things of these 3. Take the same thing, the same set, keeping W here, M there, and take some marriages and use a pattern of this kind, which we call many one. This pattern of marriage was found in Ramayana. In that epic, King Dasharatha had 3 wives, Kausalya, Sumitra and Kaikeyi. Those 3 queens belong to a single king. So 3 queens and a single king. This was also a tradition in India years ago, millennia ago. But if we put some other traditions from some other epics, taking the same pattern, taking 3 women and 3 men, and a marriage taking place in a reverse pattern, did such things happen in regions somewhere in our world? Yes, in the days of Mahabharata, you have seen a single woman, Draupadi, getting married to five brothers, Pandavas, and that was also a one many relation. So that was one many relation. And if you have three men and three women and connect them for marriage sake, if you connect like this, forgetting the patterns, will it actually appear like a marriage or a football match? Is it a general football game when in the recess there are 20 to 30 students running after a football in a high school playground, and anyone can kick the ball to anybody, and there is no goal post, no aim, nothing of the sort. So such things may be called many, but actually they are not marriages. There is chaos, there is chaotic event. This is not a marriage, this is not a discipline. And what are the relations? These are the four different relations. If we call each one a marriage, then what are the, so each one is a relation, because it is a man-woman relation, man-woman relation. But will these relations be called marriages? In society we have norms and conditions, we have rules to govern them. So in India these two patterns are allowed. You have seen in many families these patterns still operate, where a man is allowed to take more wives, but a woman is not supposed to take more than one husband in our country, in India. But in foreign countries, women or men can leave their men or women as many times as they like, but they have to legally separate. So leaving those things, let us come back to this counting principle, and out of the four different man-woman relations, only two in India are allowed by the society, and this from the, you have to take legal permission from the court, but traditionally these things are allowed and these are not. If I have three sisters, I can get them married in this pattern or that pattern, there will be no social problem. But if I get them married in these two patterns, there will be chaos, there will be problem, there will be tension, there will be a lot of blame game. So these two are not allowed. So these two will be called functions, because they function, they work, they still work. But all four are relations. So what are functions? Functions are restricted form of relations that actually work. In the chapter relating to relation function, we shall go in details, but you can see how many marriages could take place between 3 and 3. You can clearly count, there are 9 marriages, 3 plus 3 plus 3, 9 marriages. So the marriages were 3 into 3 here. In this, there was the number of marriages is 3. Here the number of marriages is also 3. Here the number of marriages is 3 into 1, so 3. Here it is 3 into 1 into 1. So all these are 3 except 1, that is 9. So counting principle looks like something like this. If we have, say, in a first set, let us forget the women and men type, let us take two sets A and B. Here there are n elements, say A1, A2 up to AN, and here there are m elements, say B1, B2 up to Bm. Then the number of relations, if f is a relation here, f of A is equal to B, f is a relation from A to B, then the number of relations will be m into n, which is the cardinality of A into cardinality of B. This is the number of relations. But the number of functions, if we take the same A and B and have a function f defined over them, so that f of a is b and f is a function from a to b, and we have the same number of elements a1 a2 up to an and b1 b2 up to bm, so that we have cardinality of a is equal to n and cardinality of b is equal to m. Then the function, the relation a cross b has the number of elements m into n when it is a relation, but in case of a function the number of functions becomes m to the power n, that is the number of elements in b to the power number of elements in a. So this is the difference between the two patterns. This is number of functions. Then why such things occur? That is the thing we have to study. Why in permutation combination there is in one we have just a simple multiplication and in the other there is a index, there is a power. Why so? I am taking some examples for number of relations. Why such thing occurs? The number of relations for f is a relation from a to b where the cardinality of a is n and cardinality of b is m is mn. Why such things occur? So let us take three things here, say a1, a2, a3, and take four things there, b1, b2, b3, say two things only, take two things only, so that it becomes smaller one to understand, easier. So let us have a relation. If f is the relation between a and b, then what is f? What is a cross b? The Cartesian product. Take any member a1 and connect it to the other two, all the members of b. So a1 b1. Next pair is a1 b2. Similarly with a2 we can get a2 b1 and a2 b2. For the third one we get a3 b1 and a3 b2. So we have 6 pairs, which is equal to 3 into 2. So a cross b, the cardinality of a cross b becomes 3 into 2, 6. That's why if a cardinality of a is n, cardinality of b is m, then cardinality of a cross b becomes mn, which is the pattern used for number of relations. But what function is? Suppose there is a film hall. A film hall has 4 doors in each direction, and there is a person who is to enter it and again exit. In how many ways a person can enter a film hall with 4 doors and exit? That problem is a function problem, that can also be a relation problem. In case it is a relation problem, we can use it like this. Say this is entering and this is exiting. You have 4 doors here and you have 4 doors to exit. So number is 4 into 4 is equal to 16. This is simple. But what is a function type? You have 4 doors here, door 1, door 2, door 3 and door 4. What can a door do? What can it help? How can it help us? We can go through it, enter, and we can also come through it, exit. So every door has 2 functions. It can allow you to go inside and come outside. So it has 2 functions, say enter and exit. So each door is going to give you two functions, door 2 the same, door 3 the same, door 4 the same. So you have every time you get two things. So you have, or these four doors can be used each time in two ways. So 2 into 2 into 2 into 2, this gives you 2 to the 4, which is 16. Or if you have doors on this side, and the functions that side, that can be 4 square or 16. So the formula pattern is, if this set is A, this set is B, then here is a function, and if this the number of elements here is m, number of elements here is n, then number of functions is m to the power n, and here it is 2 to the power 4, so 16. So this is about the counting principle, and for this we define the number of functions for f is a function from a to b, where the cardinality remain the same, n for a and b, m for b will become m to the power n. And here we end this section, the counting principle, and in the subsequent classes we shall go for permutations, where you shall learn about the permutations of n things taken r at a time, or n pair. And in the combination section we shall go for the combinations of n things taking r at a time, which is also written as NCR. These things in subsequent chapters will help us go for the hard problems in binomial theorems, and which are also used in many aspects, many horizons, many directions in physics and higher mathematics. So till the next class, let us end this one, and I request you to go through the video from one end to the other end and have your review, and subscribe my channel Subhas classes. Thank you. Bye.